So for the past while, we've been creating scatter plots. And whenever we write an equation or put a best fit line over that particular scatter plot, that is called modeling, which is creating an equation or a line to represent the data. So this particular data is data that represents the temperature and how much ice cream was sold in any other country besides ours, because it's degrees Celsius. So just to give you a sense, like I believe 20 degrees Celsius is around 70 degrees Fahrenheit-ish. So if it's above 20, you can see more ice cream is being sold. The colder it is, less ice cream is being sold, which makes sense. On the, you know, when it gets warm, that first warm day of the year, the ice cream places are crazy busy. Like you can't even drive in them. So as the temperature increases, you can see the ice cream sales increase. Makes sense. Also, coffee sales tend to decrease, and hot chocolate, because people don't like drinking hot things when it's warm outside.
But it actually helps. Like it doesn't make you like hot if you drink coffee.
Yeah, if you take a hot shower on a hot day, it helps. Because if you get out, you feel cooler.
Yeah.
Okay. So there are two things you can do with a linear model. So a linear model is either an equation or a straight line which represents the data. You can do what's called interpolation. Interpolation means to go in between the points. Meaning, let's say I want to know how much ice cream I'm going to sell, and it's 21 degrees forecasted for that day, Celsius. You can go down from 21 degrees to the line, and then over to the left side of the graph, and you can forecast that you're going to sell $480 worth of ice cream. That's interpolation because you're going on the inside of the data points. Inter. You can also do what's called extrapolation. Extrapolation has the word extra in it because you're going beyond the data point. You're going extra. So whenever they make projections, like the United States population is projected to be so many billion in the year 2020, they're doing an extrapolation. What they have done is just what you guys did. They create a scatter plot. They write an equation, and they simply draw the line to go further. And they say, okay, if it gets even hotter, how much ice cream will we sell? All right, so in this case, 29 degrees Celsius, and they'll sell $750 worth of ice cream. So be careful, because extrapolation can give misleading results because we don't know for sure that to be the case. Like, for example, if there's a nuclear holocaust, if we have some sort of fatal disease, like there was influenza that went around during the Great Depression time, there was all sorts of big diseases and wars that wiped out populations where we were growing, and then we dropped off. So just because things are growing now doesn't mean we'll continue to grow, but that's how they make guesses, is through extrapolation. So we have interpolation, which is in between, and extrapolation, which is beyond. Now, with all of these values, we have lines that either really do a good job at modeling data or really do a poor job at modeling data. And there is a number called the correlation coefficient. The correlation coefficient is the R value. And that tells you how good a fit you have. Meaning, if it is 1, that means you have what's called a perfect positive correlation. If it's 0, there's no correlation. And -1 would be a perfect negative correlation. So if I wanted to do a study that related a person's number of hours spent studying and their GPA, that would probably be a positive correlation. The more hours you study, the higher your GPA. If I wanted to do a study that related your shoe size and your GPA, that would probably be 0, no correlation. If I wanted to do a study relating the amount of recreational drugs you do and your GPA, that would probably have a negative correlation. The more drugs you do, the lower your grades will be. So they can all work differently depending on what 2 pieces of data you're gathering. Now, the R value is found either by hand or using your graphing calculators. If you take AP Stats, they teach you how to do this by hand. It's kind of a very tedious process, so it's not something you learn in Algebra 1. But your graphing calculators can show you how to do this. This is how the correlation works. So if you guys can look at these down at the bottom, these are sample scatter plots. If all of your points are perfectly on the best fit line, meaning it's super easy to draw a line through the data, the R value is 1. This is called a perfect positive correlation because the slope of this line is positive. On the flip end of this, you have a perfect negative correlation because you can notice all the points go in a line perfectly, but the slope of this line is negative. So perfect negative correlation. And in between, you have a high positive correlation, meaning they do all go in a nice line, but they're not perfectly on the line. This is a low positive correlation, meaning, yeah, I can draw a line through it, but it's not perfect. And notice how the R values change. Perfect, I liken this like 80% does 80% job of estimating the data. Not so good, and this is no correlation. This means like it's impossible for me to create a line that goes through this data. So that's why it's a 0. This is a low negative correlation. This, I would say, looking at your scatter plots, your height versus step data, would probably be a low negative correlation. You guys can tell the slope is negative, but it didn't fall in a perfect straight line, nor is it a great straight line like this one. But it was definitely a negative correlation because the taller you are, the less steps you tend to take because your lines are longer. And then we have our perfect negative correlation. And the graphing calculator will find this for you. Any questions so far? So we found the equation of that line. Now all data will not be linear. This is called quadratic data. Sometimes data will go up and down. Sometimes data will go up, down, and up. This is exponential. I'm sorry, this is cubic, meaning you're going to have an x to the 3rd power in the equation. And this data is exponential. And this year, we're going to study exponential. We're going to study quadratic, cubic. You know what it means to cube something, but we're not going to spend much time on those graphs. That's more in Algebra 2. But you can use any equation to model data. It's not just linear. But if you say data is correlated, correlated means it has a linear relationship. Questions? So I do not think we entered this data in our graphing calculator from height versus steps. I mean, you guys, I saw a lot of you did it, but what I'd like us to do is see what the R squared value was on the height data, which I surprisingly had you hand in. So I know that's annoying. Can you guys grab your height data back? Or did you, hold on, did you guys already, do you have it in your calculator? Okay, if you have it in your calculator, you don't need it.
No, I'm not saying that. I'm not even kidding.
Okay, I'm gonna grab someone's who doesn't need theirs, so I can enter it. I have someone that doesn't want theirs.
Okay. You're right from there. We're gonna be so snoring. Are you ready? Okay.
So you're gonna hit stat and then enter, because you're entering statistical data. You do, because you don't want the prior data in there. Why do we have so many points here?
Oh.
Holy guacamole. Okay. Uh-oh. Okay, I think I messed up a little bit. 66. Sorry, 55.
No.
He just sits around like a teacher. DJ.
I didn't remember. I had school. He like 15 minutes.
He just sits all time.
Why does he do something like stuff?
Because it fun. Text.
Wasn't that 6? What?
All right, ladies and gentlemen, so I'm getting the data entered. If you have yours entered, please follow along with me. Make sure mine agrees with yours. Okay, so the key thing that most people missed when they were showing me their calculator is they missed changing their window. And if you don't change your window, you're going to see the oil change zoom and not zooming in on height versus steps data. So the X values are height, the Y values are steps. So I'm going to press window. This is not going to cut it. The heights do not range from -1 inches to 11 inches. Even babies are born like 20 inches long or so. So this is way too small. So our lowest height is 60. So I'm going to change my X-min to 59. So I press the window button. Window is at the upper right-hand corner, right here by my cursor. And then the tallest was 71. So I'm going to hit X max to 72. I'm going to go up by ones. That's just fine. The Y value information is steps, and it looks like our lowest number of steps is 21. So I'm going to go one lower than that to 20, so I have a little margin. And then our maximum was 31, so I'm going to go to 32. And instead of going up by 50s, that would make no sense, so I'll just go up by ones. Look at my lovely graph now. Do you guys see that? Am I the outlier? Oh, we have a little bit of an outlier there. Okay. So now, yeah, this should be what your scatter plot looks like. You guys won't see this, so you're going to hit graph. Okay. Now, what I wanted you to do for homework is test your best fit line. I grabbed someone's paper, so I'm going to hit Y equals, and type in their best fit line. So I'm going to hit clear and type in negative, oops, that's not negative, negative 6 divided by 5, that's 6/5. Sure. Actually, they had 6/4 x, using the x button, and then plus 123. Negative x would be fine. Just make sure you use the negative button. Now, if I hit graph, I should see the line that they intended. Okay. Now, if you guys could take a look at the note sheet that I gave you, do you guys agree that this will likely be a low negative correlation? If you see the different scenarios on here of the different scatter plots, a low negative correlation would indicate around a negative 0.3. But again, there's a big range there. We know it's not terribly good. We have a bit of an outlier there. And so what I'm going to do is show you guys how we can find the calculator's best fit line. So I want you to hit stat. And then I'm going to have you hit the right arrow. So you're going to calculate linear regression. That's the linear best fit line. So you're going to hit number 4. Now your screen might differ from my screen right now depending on your operating system. If yours has like L1, L2 and calculate there, you can just go down to calculate. I'm going to hit enter.
Mine says,
whoa. Now, if we had the same things entered, most of you will have what I have, except you might not have the R values.
Yeah, I had the A.
Okay. So what that means is that the calculator found the best fit line to be y equals negative 0.66x plus 69. That is the best fit line the calculator found. Notice the R value. The R value is negative 0.69. So, 69% good in terms of a model. Now, if your calculator is not showing the R value, I'm going to take you through a series of steps. After you do this, it will always show the R value, so you never have to do it again. All right? So, I need you to press the button that says Catalog. Catalog is second 0. Now, you are going to press the button that says D.
Oh,
the X minus 1.
So this shows all of the things that the calculator has, every single thing that it has. And so to skip ahead to the D's, because it's all in alphabetical order, you just press the button that has the D under it.
So you just do X minus 1, or you do alpha D?
I just pressed X negative 1 and it went down there. Okay, now you're going to go to what says diagnostic on. You're going to press enter, and then enter again, and it will say done.
Hey, it says done.
Well, you want to go to diagnostic on, not off. Okay, now I want you to do the process again to calculate the best fit line. Press stat.
I pressed that.
Go to calculate. Remember which one it was? 4. And then enter.
And then enter.
Oh, I get R.
Oh my gosh, I have R.
Yep, so you have R, and then they square it as well as show the R squared good. So this is a moderately good fit. It's not perfect, It's not a -1, it's not a perfect negative fit. It's not too terrible either. It's negative about 70%. So that means, as far as its ability to predict the number of steps, if we had someone come in here and tell us their height, it would do about a 70% job with predicting their number of steps. But what would help us is more data. If we asked 100 kids their height and the number of steps, perhaps we could get better data here. So that is how you can find the R value given the graphing calculus.